Okay, so the last video about the control register got abruptly interrupted. So again starting from the same thing. 0H means linear addressing mode selected for these registers in appropriate. So 2-bit selection is there for every register from A4 to A7 and B4 to B7. Now when these 2 bits for B7, that is bit number 14 and 15, are selected to be 1H, that means 0 and 1, then circular addressing mode with BK0 field will take place. Now in BK0 field, as I told you, that is if it is all zeros, then it will be 2 raised to 0 plus 1, means n is equal to 0, that means 2 raised to n plus 1. So n plus 1 is 1, so 2 raised to 1 means 2. So the smallest possible block size is 2 and largest possible block size is when all ones, 5 bits are 1, that means it is 31. So n is equal to 31, n plus 1 is equal to 32, so 2 raised to 32, that is this large number that we discussed in the last video. Okay, so 1H for BK0 selection. So for B7, block size would be BK0 if 14 and 15 bit number are 0 1. Okay, same way if 12 and 13 are 0 1, that means for B6 register the block size will be selected from here BK01. Okay, same way when this combination of 2 bits for every register is 10, that means 2H 10, that means circular addressing mode with BK1 field. So it is very similar to BK0, but now the selection will come from here, the values of these 5 bits, that means bit number 21 to 25 in this particular position. So BK01 values, same way here the range is 2 to 2 raised to 32. The smallest block size is 2 and the largest block size is 2 raised to 32 bytes. When we say 2, that means 2 bytes, and 2 raised to 32, that is also in bytes. Okay, so here the addressing is in terms of bytes only. Actually this processor has several different word lengths, means data lengths, that is byte, then 16 bit means 2 byte, that is called half word, then 32 bits, that is 4 bytes, that is called word, then 64 bits, that is called double word, because it is 2 times 32, so 32 is called word, so 64 bit length is called double word, and 16 bit is called half word, and 8 bit is called bytes. Okay, so this is the way we refer to various data lengths, but here when we refer to the blocks, so it is always in terms of bytes. Okay, so read and write can be performed by MVC instruction. As I told you that for MVC instruction to access to these registers, all control registers, the S2 unit, .S2 unit is used for in every case. Okay, so this is the addressing mode selection. Particularly when you select circular addressing mode, then we have to configure the AMR register. Okay, the next register, that is control status register 2.7.4, CSR is acronym, and page number is 39. So this is another control register that is also 32 bit, so lower 16 bit and upper 16 bit. Upper 16 bit 24 to 31 bits are reserved, and that indicates CPU ID. The values possible are 2H and 3H for 67X and 67X plus. Okay, and revision, the revision ID is given in 16 to 23. You cannot write these values, so they are reserved values. Now coming to the lower 16 bits, so bit number 10 to 15, these 6 bits are representing power down mode. So how to select power down mode, that will be selected from the selection of the bits over here. Okay, the most significant bit, most MSB is reserved, so it is always 0, and these 5 bits, so first bit is for first these 2 bits are for enable interrupt and enable or non-enable interrupts, power wake up for power wake up, and these are three different modes of this power down: PD1, PD2 and PD3. So PD1 and PD2 are always wake up on reset, and PD1, so in that case this bit is always 1. So we will see over here. And PD1 will have two options, whether it is with only enable interrupt or enable or non-enable interrupts. So these are the modes. So next, so here we see in detail. So power down mode, 0H means no power down, 9H, 9 means 00 and 1001. So mode 1, mode PD1, wake up by enable interrupt. So for that, this particular enable interrupt this position is equal to 1. Okay, so that's why this position is equal to 1 over here. Then 11, so this position is now 0 and this position is 0 1. So now enable or non-enable interrupt. So let us read this. Mode PD1, wake up by enable or non-enable interrupt. Okay. Then when 1A value is selected, then this is the binary form. So these are the bitwise form. Okay. So PD2 wake up by device reset, and PD3 is also the same, that is 1C. So when you select 1C, 0 1 1 1 0, then it is PD3. Okay. Then next bit is 9th bit, that is for saturation. So while performing any operation, any of the units go into saturation, then this saturation bit will set. So we can not set saturation bit at our own, we can clear it by MVC, but it is set by the functional unit while when it goes into saturation. So that is saturation bit. Then next bit is 8. 8 bit is endian mode. So which endian mode? Big endian or little endian. Now what is meaning of endian? Big endian and little endian. So when we write, the question comes when it is the data length is more than byte, that means 16 bit or 32 bit or 64 bit. Here we are taking the example of 32 bit data. So 8 and 8, so altogether it has got 32 bits. So 32 bit data is typically this example 2A61B374. In hexadecimal values it is represented by this. 2A is most significant byte over here. So when most significant byte is written in the lowest address, that is here the address starts from 00, 01, 10 and 11. So when it is written in the lowest address and subsequently the bytes are written, next byte is written over here in the next address, then B3 is written over here in third position, and the least significance byte is written in the highest address value, then it is called big endian mode. And vice versa, the reverse of it, when the least significant byte is written in this position 74 is the LSB byte over here, which is written over here in first 00 address, and then subsequently in reverse order it is written like this when 2A is written over here. So it is called little endian mode. We cannot write this bit over here, we can simply read this bit. Okay. Then next is PCC, program cache control, and selection is either 0 or 2H. Okay. So that is controlling the program memory, in internal program memory. And DCC, that is again 3 bit setting, that is data cache control, that is two-way data flow is there, that is controlled by these values 0 or 2H are the possible selections. Okay. And next bit is PGIE, and next bit is in 0th position GIE. What is GIE? GIE is global interrupt enable. So to make enable any of the interrupts, we have to set this bit to 1. Okay, and PGIE is a copy of this GIE. When any interrupt occurs, then this GIE bit is simply copied over here and preserved for some purposes. So it is required, the detailed usage of this is explained in interrupt instructions. So right now I am not going into the detail, but this is required. So GIE is global interrupt enable, and this PGIE is previously written global interrupt enable. Okay. So this is, I think, about the control status register. Okay, and we discuss also about AMR. So we have discussed about two different control registers. One is AMR and another is CSR. Okay, so if you have any questions, you can ask me directly in the group or by email. Thank you very much.